Today is all about exponential equations. You were supposed to fill this out before you watch the video, so hopefully these are the numbers that you have, and we will be referring back to it. I'll be talking about it, so have it out, please. So exponential equations are equations that contain a power with a variable as an exponent. That means the x is now in the exponent. So this is the first time we're seeing it. We're not doing anything too deep, but it's, should be fun. So the basic idea is isolate the power. This is what we do all the time. Isolate the weird thing so we can get rid of it. Write each term as a power with the same base and set the exponents equal to each other. So that's the idea. So 2 to the x can't really be changed. But 8 here, if you look on your chart, 2 to the third is 8. So what we always want, we want these bases to be the same. Once the bases are the same, we can get rid of them because the bases are the same. We just want to get these numbers the same. So that means x has to be 3. And that's the basic idea behind these. You know, there's intricacies, different things that happen, but that's the idea. Okay, next. Oh, I thought I went to the next one. Sorry. All right, so here we go. We're looking at a 4 and an 8 as our bases. So you look at the 4, you look at the 8, and you look at your little chart. I unfortunately can't refer back to it, but your little chart. Is there anyone where the answers are 4 and 8? So what I'm saying is, excuse me, we have 2 to the 0 power is 1, right? 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3 is 8. These are the answers that I'm talking about. We want to find these numbers in the answers. And that means we can rewrite them with those exponents. So 4 is 2 squared. Okay? And 8 is 2 to the third. Okay? Now this is how you're supposed to write it. But this is how I'm going to write it. Okay, because you know this is power to a power, so you know that you're multiplying these two. But this seems to have better results, that you remember you have to multiply that 3 into both pieces. So it is up to you what you write. I like it that way better. So then you do this, and you solve. So negative a equals 3. And a equals negative 3. So if I plug a negative 3 in here, this will, into both of those spots, it'll make the equation true. Okay, so this is the idea behind, you got to make sure the power is isolated. So the 7 is being raised to the x plus 1 power. It's not alone. You've got to get rid of this 3. If you get anything out of this class, that should be one of the things. Okay. 7 to the x minus 1 is 7. Well, the bases are the same, but what's the exponent over here? The exponent over there is 1. So now when we drop the bases, it's x minus 1 equals 1. Solve, and x is 2. Good? Good. All right, so here, 125 and 25. I see the 5s, and I think 5. So we look at our column, 5 to the 0 is 1, 5 to the first is 5, 5 squared, 5 to the third. Okay, so these are the two that I want, because I have 125 and 25. 125 is 5 to the third, and we multiply them like that. 25 is 5 squared. Drop the bases, and we get 3 times x minus 1 equals 2x, and we solve. So x is 3. So if we plug a 3 in here, it's always good to check, but more like a visual check to make sure it works. Okay, same deal here. What's the thing being raised to the 2x minus 4 power? Well, that is just the 9. So that 6 is not welcome. The 6 is connected with multiplication, so I divide to get rid of it. So this winds up being 1 equals 9 to the 2x minus 4. So how do I get these bases the same? Well, I know that anything to the 0 power is 1. So I have a 9 here. I can make it a 3, but there's really no need. This 1 is really 9 to the 0 power. Whatever base I have, if I raise it to the 0 power, it's 1. So now I drop it and solve. So 4 is equal to 2x. So x is equal to 2. All right, when you have a fraction, you remember fractions, when bases are fractions, that means the exponent is negative. Okay? That's the basic idea. If we make it negative, then we can flip it back. So what that means is, what I like to do is look at the 125 and the 25 first. And I kind of ignore the fact that it's a fraction. And I look at it, well, 125 is 5 to the third. And then it'll be x plus 1. But since it's in the denominator, that means that this should be negative. That's it. So rewrite this with the correct positive exponent, and then since it's a fraction, make it a negative, and what that in essence does, it moves it up and makes it so that it's not like this isn't a fraction anymore. So this is 5 squared. Drop these, and I get the negative 3 times x plus 1 equals 2 times x plus 1. Okay, and then we solve. So add 3x, subtract 2, negative 5 equals 5x, so x is negative 1. It's basically saying the only way we're getting these equal is if the exponent is 0. Okay, this one's pretty exciting. I can't really combine these two. I can't get rid of it. So what I need to do, this is a time where you may want to change all of the exponents right now. So that means we have to find an 8, a 16, and a 1024. Oop. So the only thing I know would be 2. 8 is 2 cubed. 16 is 2 to the 4th. And 1024, I believe, is 2 to the 10th. So I just replace all of those. So 8 is 2 to the 3rd times x. 16 is 2 to the 4th. And 1024 is 2 to the 10th. But since it's in the bottom here, I make that a negative. Look, all the bases are the same. Now I can't just drop them here. It has to be a base equal to a base. So what I need to do is combine these two. And remember, when you multiply bases, you add your exponents. So this is 3x plus 4 times x plus 1. You could actually do the math here, distribute that 4 through and add them, but now we can drop it. It has to be one base. Okay, so this is how we use our exponent rules. A little bit more involved. So 7x equals negative 14. X is negative 2. Okay, so we're using, when you combine, when you multiply bases, you add the exponents. Okay, that's all. We did a lot of those. Hopefully it's pretty straightforward. And finally, same kind of difference here. 25 is 5 squared times, 5 to the negative 2 power, 2x, equals 5 squared. Since it's in the denominator, we make it negative. These two combine. In order for those to combine, I add them. 2 plus a negative 2x, so that's just minus. And these get dropped. So you can only have one base. to a power equal 1 base to a power, and then I can drop. So it's 2 minus 2x equals negative 2, and we solve. So it's negative 2x equals. So x is 2. Okay, the basic idea, we need common bases, follow your exponent rules, and all is well. See ya.